Okay, so now we are looking at practice problem 8.6. Calculate the pH of a sample of blood that has this hydronium ion concentration. And the point of this example and the next one is just to say that sometimes pHs can be decimals. They don't just have to be like a 4 or an 8. All right, so let's see. They gave us a hydronium ion concentration, and it was 3.3 times 10 to the negative 8 molarity, which is different from what we've been seeing, because we've been seeing 1.0 times 10 to the negative something. Okay, so we know that the formula for pH is the negative log of the hydronium ion concentration. So I just plunk this number into here and stick it in my calculator. You know what? I keep forgetting that I don't have to do brackets there. Well, your textbook does brackets, so I guess it doesn't matter. All right, let's go over to the calculator. So, the calculator. I am going to say negative log of, what was it, 3.3, and I'm going to go second comma to get the scientific notation, and that was a negative 8. Don't have to close the parentheses, but I do anyway. 7.48. Let's see, we started out with 2 sig figs, so I'm going to round this to 7.5 so that we'll end up with 2 sig figs. So that is a pH of 7.5. All right, let's go ahead and see if we can tackle the next practice problem. That is practice problem 8.7, part A. And let's see if I can bring that to you. That is over here. Calculate the hydronium ion concentration corresponding to a pH of 8.50. All right, not dissimilar from what we've done before. We're asked to calculate, oops, not in camera, asked to calculate the hydronium ion concentration given a pH. So we kind of figured out before that all you have to do is say 10 raised to the negative pH, and that will give you the hydronium ion concentration. And that's easy to stick in your calculator. And just in case you haven't watched the previous video, it comes from this. So we have the pH formula, and we stick in our pH, and we need to find the hydroxide. We divide both sides by -1, or we just move the negative sign over. And then we can talk about it like antilog, or we can think about it like back in college algebra, and we came to the conclusion that 10 raised to some power equals the hydronium ion concentration, which is what you see when you go to the calculator and you type in the antilog, or you hit second log to get the antilog. So now that we've learned that, let's just go ahead and set it up this way, because I think this looks way less intimidating. So we can go over to the calculator and put in 10 raised to this power, but I want to show you the whole antilog aspect of it. So I am going to still use that. So I'm going to hit second log. Look at that, 10 raised to some power. And so I'm going to go down here and say negative 8.50. And that gives us 3.16 times 10 to the negative 9. And I stopped at the hundredths so that I would have 3 sig figs, because we started out with 3 sig figs. Remember, this 0 counts. It's It's a trailing 0, but there is a decimal in the number. It's the only time decimals matter, when you've got a trailing 0. Anyway, 3.16 times 10 to the 9th. -9th. Molarity. Forgot to write that in. Okay, let's see if we can quickly do the next one. Practice problem 8.7b. They want us to find the hydronium ion concentration, but this time they give us a pH that equals 4.50. And I'm getting that from right here. Hydronium ion concentration, 4.50. All right, same deal. 10 raised to the negative 4.50 equals the hydronium ion concentration. So you go to your calculator, push the second button, push the log button, because on top of it it says 10 to the x, and then you'll see a 10 to the x on your screen, and you type in negative, you hit that negative button that's down there at the bottom, 450, and then you hit enter. Easy peasy. All right, I'll see you in the next video, and don't forget you can slow down the playback speed by going to settings in the lower right hand corner.